Hi, my name is Injay, and welcome to this series where we unpack different parts of the AI hypercomputer stack to see how it works, what problems it solves, and a quick demo to see it in action. Today, we're going to be diving deep into how you can serve embedding models on TPUs. But before we jump in, let's quickly ground ourselves. What are embedding models? Well, simply put, it takes in different types of data as input and outputs dense vector math. The most common popular use cases for these are recommender models, semantic searches, and clustering. For example, you might search for cat and you get a higher rating on feline or dog rather than a hat or a car, which is more similarly spelt. The example we'll be looking at today is a text embedding model serving on TPUs. As you scale your applications to millions of queries, you're going to quickly run into a few different bottlenecks. And the most common ones that we see are improving your cost performance efficiency and having more elastic capacity of accelerators so you can scale up and down to better closely match your traffic. And the way we've done this is by adding support for TPUs on vLLM, which is a highly popular open source framework for serving large language models. Now, the best part is that you can build true elastic architecture for your serving stack. By standardizing vLLM, you can add TPU nodes right alongside your GPU nodes to seamlessly scale up and down on your traffic. And better yet, by using primitives like custom compute class, you can automate this process of scaling up and down using different types of consumption types or even using different accelerators. And with that, I'm going to hand over to Anthony to have a quick look at the demo.
Thanks, Injay. I'm Anthony, a software engineer at Google Cloud. Let's get into the technical part and see how easy it is to set it up. We are currently sitting inside a Google Cloud TPU V6 VM. First, we install the TPU optimized version of vLLM. It is a straightforward pip installation targeting the open source vLLM repository with TPU build flags. Next, we will launch our vLLM server. We specify our target embedding model, in this case, a massive open source model. vLLM automatically optimizes the model weights across the TPU cores using underlying XLA compilation. The OpenAI compatible API server is now up and listening on port 8000. Let's test it. We will send a standard HTTP post request containing a sample text prompt to our /v1/embedding endpoint. Boom, fast response. There is our high-dimensional vector array, ready to be indexed. To see how it performs under load, we will send another VM server benchmark. We can now see the VM benchmark result with this sample. The performance metrics includes benchmark duration, request throughput, token throughput, and latencies. To recap, we just took enterprise-grade embedding model deployed on Google Cloud TPU with vLLM framework in just a few comments. We verified its accuracy and showed its amazing performance with high throughput and low latencies. Looking ahead, this TPU-backed vLLM structure supporting next-generation multimodal embeddings models. You can process text, image, video inside enterprise pipelines. To accelerate your AI inference, head over to the Google Cloud console, spin up a TPU VM, and check out our official documentation and the vLLM guide at the links below. Thanks. See you next time.